Introduction. Timetable clashes are a common issue faced by university students when two or more subjects are scheduled at the same time. This project aims to solve the problem using a graph theory method called graph coloring, each subject represented as a node. And if two subjects have overlapping students, a connection is made between them. Different colors, which is time slot, are then assigned to ensure no clashes occur. The project focused on 10 subjects from the CS248 program to create a conflict-free schedule for students.
Next is the problem statement. Timetable planning in higher education can be a real challenge, especially for students in the CS248 program who often take multiple subjects. Many times, these subjects clash by running at the same time, forcing students to miss classes or juggle between overlapping sessions. This not only adds stress but also affects their academic performance. Currently, the manual approach to scheduling is inefficient and prone to errors. That is why this study proposes a smarter solution using graph theory. In this method, each subject is treated as a node, and conflicts where subjects share the same students are represented as edges. By applying graph coloring, we assign different time slots to conflicting subjects, ensuring no overlaps. This approach helps create a conflict-free and efficient schedule that benefit both students and also academic staff. So moving on to the objective. For our group project, we have two objectives. The first one is to construct a conflict graph based on the CS248 core subjects by identifying overlapping student enrollments that cause scheduling clashes. The second one is to generate an optimized class timetable by applying graph coloring techniques, ensuring that no conflicting subjects are assigned to the same time slot, thus improving schedule efficiency and student accessibility.
This project aimed to avoid two subjects being scheduled at the same time, thus avoiding overlapping schedule among students. These are the 10 subjects that need to be taught in a day. Thus is a conflict, which means two or more are running at the same time or overlapping. The adjacency matrix had to describe a graph in the form of the matrix that show the relationship between each vertex in the graph. The adjacency matrix provides a visual representation in easy to understand form if the number of vertices is too large. This table shows the alphabet symbol that represent each cause and conflict in alphabet symbol. Through the alphabet symbol, we can construct an adjacency matrix. A value of 1 indicates that there are relationship between each symbol.
Okay, next I will present a network graph. A network graph represents a mathematical graph or structure to illustrate relations between points aesthetically pleasingly. The graph visualizes how courses are interconnected with each other. The course scheduling problem is particularly used in institutions where courses are scheduled and some courses can be taken at the same time due to student and enrollment overlap, classroom capacity, or course prerequisites and sequences. In that graph, each node represents a specific course, and the edges between the nodes signify conflicts between those courses. These conflicts occur when two courses have students enrolled in both, meaning that they cannot be scheduled in the same time slot. Each node in the graph represents a course offered by the institution. The edges between these nodes indicate a conflict, which implies that these two courses cannot be scheduled in the same time slot. This project can apply the graph coloring method to solve the course scheduling problem. This method is particularly effective for problems involving conflicts, such as assigning courses for time slots in a timetable. It aims to assign a color to courses, and each color will represent a time slot where there are no two connected nodes that share the same color. Okay, figure illustrate the presence of edges between two nodes of MGT 400 with MAT 530, MAT 560, and ENT 600, showing that there is an overlap in courses schedule that requires these courses to be assigned to different time slots. Since these two courses are directly connected, the course scheduling needs to be carefully arranged to ensure there is no clash. Then courses with multiple edges like MKT 410 show a conflict with QMT 634, MAT 523, and MAT 668 that cannot be scheduled in the same time slot. In the context of scheduling problem, these courses need to be scheduled for the upcoming semester or academic period. Each course must be assigned a time slot in a way that respects the constraint imposed by the conflicts between courses. In addressing these conflicts, the scheduling process requires carefully planning and optimization to avoid overlapping students' courses in their timetables. The vertex coloring method is the method to solve conflict graph for cost scheduling. In this method, each cost is represented as a vertex and the edges between vertices represent the conflict. The process begins by randomly selecting a vertex and assigning it the first color. The project chose MAT 530 to start and assign the vertex with the color pink. Cos MAT 530 is adjacent to MGT 400, meaning these two vertices cannot share the same time slot. Therefore, the vertex of MGT 400 is assigned with different blue color. Next, continue this process for all other vertices and ensure the two connected vertices do not share the same color. However, other graphs are not connected, indicating that the causes are not related and in conflict with other graphs. Furthermore, if the vertex is not adjacent to any previously colored vertex, it can be assigned the same color as one of them. This process is repeated for all causes in the graph until every vertex is colored. The number of colors used to represent the chromatic number of the graph, which is shown as the minimum number of time slots required to schedule all the courses without any conflict. Even though vertices are colored, courses that share the same color can be scheduled in the same time slot, and the vertex with a different color needs to be scheduled in a separate slot. Table shows the color representation for each course after applying vertex coloring, which is for color pink, the courses is MAT 530, MAT 560, and MKT 410. For next color blue, MGT 400, QMT 634, and MAT 668. Next, the green color, ENT 600 and MAT 571. And the last one is yellow color, MAT 633 and MAT 523. A figure represents the graph that has been colored for each vertex by time slot. The chromatic number of the graph is 2. This means that the minimum required slot is 2 times to schedule all the courses without conflict.
So the next one is the suggested table. The suggested timetables are presented in two parts, which is the first table shows the suggested timetable based on courses and also time divided by the existing time slots. After performing vertex coloring and obtaining the results, the outcome will represent the timetable that assigns each course to one of the 4 time slots. There are 4 time slots based on the conflict graph. So for the first time slots, there are courses for MAT 530, MAT 560, and also MKT 410 at 8 a.m. until 10 a.m. And for the second time slot, there are courses MGT 400, QMT 634, and also MAT 668 at 10 a.m. until 12 p.m. For the third time slots, there are courses ENT 600, MAT 571, where the time is 2 p.m. until 4 p.m. And for the fourth time slots, there are courses for MAT 633 and MAT 523, and the time is from 4 p.m. until 6 p.m. So this one is the second suggested table, where it is the same from the previous suggested table, but this one is a more detailed suggested table where it has the time slots, courses, room, student group, lecturers, and also time for all the courses. This scheduling ensures that there are no two conflicting courses that assign to the same time slot while minimizing the total number of time slot required. Furthermore, the schedule keeps the student and lecturers from having classes that overlaps. It also benefits the institution by reducing the number of time slots needed, allowing for a more compact schedule, guaranteeing better use of resources such as lecturer and also the classrooms.
In conclusion, this project successfully applied craft coloring to solve timetable conflicts in the CS248 program by modeling subject as vertices and conflict as edges. The coloring ensured that no overlapping classes occurred, allowing for a clear and efficient schedule using only 4 time slots. This approach not only reduces student stress and optimize resource use, but also prove that mathematical concepts like graph theory can effectively address real-world academic scheduling problems.